everyone, I'm out here at Jacob's Well in Wimberley, Texas for my Geography in My Backyard project. I wanted to come look at some of the natural processes that shape this area, especially how water and limestone interact to create features like this one. Jacob's Well is considered an artesian spring. Though the flow is low right now, you can see algae gathering where water would normally bubble up. This is a sign of reduced pressure from the aquifer beneath. A big part of what makes this place special is the Karst topography, the landscape that forms when slightly acidic rainwater dissolves the limestone underground. Over time, that chemical weathering creates caves, sinkholes, and springs like this one. You can see that process in the curved shapes and small holes in the limestone that show where it's been dissolved by water for thousands of years. Let's take a closer look. You can actually see where the water has been eating away at the rock around here. Jacob's Well is actually one of the longest underground caves in Texas. Divers have explored it down to around 140 feet. That's like the length of 4 standard school buses. It connects to a massive network of underground tunnels that supply the hill country with water. This whole area is part of a riparian zone, the term given to a transition area between land and water. It's super important for filtering runoff before it gets into the creek. Oh, hey there! Did you know that limestone dissolves so easily because it's made mostly of calcium carbonate? The same stuff found in seashells and chalk. When rain mixes with carbon dioxide, it forms a weak acid that slowly eats the limestone away. Jacob's Well feeds right into Cypress Creek, so this is also a great spot to look at how surface water moves and reshapes the land. As the creek flows over this sediment bed, it gradually wears it down, carving small, shallow steps and channels like the one you see here. These are formed by a process called stream erosion. Another process that's great to see out here is how the vegetation interacts with the land. These big cypress trees and their roots help hold the soil into place, which reduces erosion along the creek. You can even see in some places where roots are exposed as a result of the soil around them being gradually worn away by running water. Another great example of physical weathering are these rocks right here. As you can see, there's little cracks and flaking on the surface from temperature changes or water seeping in. And the chemical weathering that I mentioned earlier reshapes the limestone slab over time. Hey, over here. It's been a while. Let's take a look at this. You see how all these roots weave kind of in and out of the soil here? Without this vegetation, heavy rain would wash away the topsoil really quickly. That's one reason conservation groups monitor this area, to keep native plants growing and to protect the creek. Speaking of conservation, there are roughly 7 untouched and protected acres along Cypress Creek that have never been farmed or built on. It's like a little time capsule showing what Texas could have looked like centuries ago. Even though this place looks stable, it's constantly changing. The rocks are slowly dissolving, the creek can shift its path, and the spring's flow rises or falls depending on how much water we get. I mean, if you look over here at the water line, it's pretty obvious the water level has fallen over the past few weeks. Overall, both of these areas are great examples of how physical weathering, groundwater, and surface water work together to shape the landscape. Seeing it in person really exemplifies how erosion and deposition are always connected, and how water doesn't just passively flow over the land, it shapes it from above and below. Well, this is it. Thanks for coming along with me to film my Geography in My Backyard project. I hope you learned something, and I hope to see you soon. Bye!